look at the patterns here. Cosecant of x, cotangent of x. There's another one. Derivative of tangent. Secant squared of x. What's the cotangent then? Well, look at this. Tangent is secant squared. What do you think cotangent is? It's negative. That's right, because all the co's are negative. Cosecant squared. Oh, what about the derivative of a to the x? It's a to the x times the natural log of a. I can take the time if you want, but what about the derivative with respect to x of the log function? Okay, you're never going to see 1 over x squared. Not going to happen. The derivative of a regular base log, log a of x, I will do this. I will do a change of base, so it's the natural log of x divided by the natural log of a. Keep in mind the natural log of a is a constant. So I can ignore that constant, pull it out of my derivative, and the derivative of log of x is 1 over x. Yes. A to the x ln a. And remember this because it almost spells my name. L-A-N-A. Okay? So ln a, that's, you put an a there, that would be, I'm sorry, an a there, you'd have my name. Okay? These derivatives? No, you just have to know them. Did I get?
Will there be like multiple choice questions where they have to ask you like what's the derivative?
No, it'll be with the composite function.
Won't be that easy.
No, it won't be that easy. Think of the exam as R3s and R4s.
All right.
Oh, it's just the way it is. Okay, were there other ones you wanted me to do for the derivatives? Let's do antiderivatives then. Now, how do you know you have an antiderivative? That's right, take the derivative. Okay, so we have to go back. So what is x to the n? Okay, Zach, what's the antiderivative of this? X to the n plus 1 over n plus 1. Okay, guys, what can't n be? Negative 1, because you get division by 0. But what you do when you get the negative 1 is you have the 1 over x, which is the natural log of the absolute value of x plus c. You can open them up. But now, you guys, why is the absolute value there for the natural log? First, if I take the derivative of the natural log of the absolute value of x, Stephen, then I actually get 1 over x if there's an absolute value symbol there. But the other reason I would like to have the absolute value in there is if I say the integral of 1 over x dx is equal to the natural log of x plus c, I have a condition that x must be greater than 0. Can't take logs of negative numbers. But if I put in the absolute value symbol, then x just can't be 0. So I have a bigger domain. And if I take the derivative of the log of the absolute value of x, I will get 1 over x, even with the absolute value symbol in there. And we can, I don't know if we have time today, we can do it tomorrow. So have you tried these integrals? You need a full list of these because you need to make every antiderivative you're going to do in this class look like one of these. And you're going to have to do what we call a U substitution. You're going to have to simplify it. So there's and we didn't do this integral. I should write it down in case we get to it. We might get to it today. I hate that when that does that. But it's integral of sine to the fourth of 3t cosine of 3 dt. And we're going to do a U substitution. On my back, my BC calculus kids did this. I would be lost without you. Yeah. So you can see it on my back. Okay. So if I find the antiderivative here, this is the cosine of x plus c, but what else needs to be there? Negative. What about the cosine function? Sine of x. Tangent? Well, we can do the tangent later. You don't have to know this one. Yes. We do not have to memorize those. Now, looking back at your derivatives, the integral of secant tangent is what? The secant of x. I'm going to take this real slow today. If it's too fast, you can tell me. What about this one? Cosecant cotangent. Cofunction. So it's negative. Well, if secant tangent is secant, cosecant cotangent is cosecant. It is. That's what math is all about. Patterns. Well, this one's easy. See, we don't know what to do with composite functions because there's no rule for it. Because you have to do a u substitution and make it look like one of these. Well, if the derivative of a to the x is a to the x times the natural log of a, what's the No. If the derivative is a to the x times log of a, what do you think the antiderivative is? It's a to the x, what? What's the opposite of multiplying by the log of a? Because you're doing the other process. Divide by the log of a. A is a constant. So if this works with e to the x, because the log of e is just what? What's the natural log of e? It's 1. Okay, keep going. Secant squared. I could just reveal these, and I will. Tangent, and there is an answer key to this up online. Cosecant squared. Negative cotangent. You have to memorize these, but when you're doing the homework, have these in front of you. This is why I gave it out to you today. Oh, we did secant tangent already. We don't do it twice. What's this one going to be? Inverse sine. And the one you're going to see often on the exam is the 1 over 1 plus x squared. Inverse what? Tangent. If it's inverse cosine, what has to be in front of it? It has to be a negative. Yes. Yes, you have two choices. They're both correct. So if I take this little green thing down, because I'm going to save this for you anyway, and there they are. No, not all of them. I don't have the inverses on it. So if you were interested in the tangent and cotangent, after today, after I introduce the u substitution tomorrow, we might look at it and say, why is it the log of the cosine of x? There they are. The derivative of this is 1 over 1 minus x squared. Well, because what I did was I said this. And then I said, I don't like inverse sine, so I'm going to solve for x. X is the sine of y. And then we took the derivative implicitly. If you remember, it's good review for implicit differentiation. What's the derivative of the sine function? It's the cosine of whatever's in there times the derivative of the inside function with respect to x. So let's dy dx. So if you solve for dy dx, I like the tangent one better, but well. So dy dx is 1 divided by the cosine of y. Okay. Y is an angle. Y is an angle whose sine did I say that right? So the sine of, sorry, said that wrong. I knew I did that wrong. Sorry. Y is the angle, so the sine of my angle is equal to x. So if I draw a picture, remember when I did this? It took a while. Okay, so here's y. The sine is x And that would be 1 by Pythagorean's theorem. This is the square root of 1 minus x squared. Remember that? And then cosine of y I could write as the secant of y. I'd like to do that because that's actually easier than doing reciprocals. Okay, what's the secant of my angle? The cosine is square root of 1 minus x squared over 1. Secant is 1 over that. Now, what you have to do, is memorize it. If you forget on the exam, you can do this, but you're on a limited time. So I don't know if you have time. There are some things you must memorize. We'll give you a sheet that is on one side, both sides of the sheet of paper. Other things you have to memorize, for instance, like the pairs. Okay, I think we're ready to go on. Now, I'm sorry this was not printed out on this, so you can do these on the back of your yellow sheet. The ones we're going to do. And all those that's on your sheet, but I'm going to skip that. And we're going to try these. Whoopsie. You don't have it. Okay, we actually got left off. So, but let's do these. I'd rather start with easier problems than the harder problems. These are a little harder, and we'll get through 2 examples on here. So you're going to want to write this down on another piece of paper, and I'll rewrite it so you can read it. So, because it might be hard to see in the back. Now that doesn't look like anything that's on our sheet. It kind of looks like x to the n. So maybe, girls, I can make it be like x to the n. Can't I divide that? Isn't this the same as this? 4x to the 6th over x to the 5th plus 3x to the 5th over x to the 5th minus 8 over x to the 5th. Can't I do that? Divide everything by that. Some of you made it x to the negative 5, and that's fine, but I think it's harder. It's harder for me. So this is 4x plus 3 minus 8x to the negative 5. This is little f. So what's capital F? I don't have a lot of space here. So find the antiderivative of 4x. Colin, what is that? It's just the power rule. So it's 4x. We go up by 1. No, this is x to the first. No, you have to have it divided. We don't have a quotient rule. Yeah, no, I know it's not on your sheet. I told you. Sorry. I'll get these printed out for you, too, if you want them. How did I get what? I divided this into 4x to the 6th. Then I divided x to the 5th into the middle term, and x to the 5th here. I wrote that as a negative x bar. That's 4x, x to the 6th over x to the 5th, x to the 1st. Yep. And this is 3x, or 3, sorry, minus 8x to the negative 5. It is hard to see my negative, sorry. I don't have a lot of space. So what's the antiderivative of 3? 3x minus 8x. Let's go up by 1. Negative 4. I want to make it negative 6 too. Divided by negative 4 plus c. I don't care if we simplify. Not a big deal. You could have done it x to the negative 5th and distributed that x to the negative 5th. You will get the same thing. I think that's easier, but so when I do b, I have a problem with that. If you try to make it y squared plus 4y to the 3rd over 3, and you take the derivative of that, you have a composite function. I have a function, y squared plus 4y, inside of the squaring function. So I have to do the chain rule. So Jacob says, why don't we just multiply it out? I got a problem just to the 8th. But square it, sure. So it's going to be y to the what? 4th plus 8y to the, careful, you're going to multiply these two together and double. No, you don't double the exponents. It's y squared times 4y times 2. So it's y cubed plus 16y squared. Some of you forget to square the 4. And then there's a dy there. It's important to have that dy. Remember what an integral is. It is an area under the curve. That's the base of my rectangle. This is the height of my rectangle. So that's just the area under the curve. Turns out it's also the antiderivative. And it bothers some of you that it's both. But it is. And maybe after the exam, I'll prove it to you. Okay? I won't be able to prove it before that. Well, I can. I don't know if we have time. So what's the antiderivative of y to the 4th? Y to the what? 5th over 5. What didn't I write? I didn't show you the foiling. Plus 8y to the what? 4th over 4 plus 16y to the plus c. Yeah, it is. Let's run multiple choice. Okay, you girls got it? Now, there's new stuff. This is stuff we already know how to do, hopefully. But here, we're going to do a u substitution. This is x squared. I got to go through this slowly. I don't want to cube that. I know you don't want to cube it also. And multiply by 2x. But that would be a way to do the problem. Instead, I want to see if I can make this expression here, this whole thing, look like just the power rule. It's how we deal with composite functions. So what I'm going to do is what I call a u substitution. It just makes the integral easier. Some of you can see it, and some of you can't. It's okay. It doesn't matter. So I'm going to let u equal x squared minus 4. So now what I have in my integral is I have the integral of u cubed times 2x dx. Well, that's a problem, right? Can't have the letters mixed up. I need to be with du's. I need u's over there. So let's take the derivative of this. Du with respect to x is what? What's the derivative of x squared? It's 2x. So if you solve for du, it's equal to 2x dx. Guess what? 2x dx is the same as du. So I could take this and replace by du. Any of you golfers? Besides me? Okay, when you take relief in golf's got very complicated rules. You must take full relief. If you ever watch the golf, if your ball's on the cart path, you say, okay, I want to get relief from the cart path, because you don't want to hit your club on the cart path. Kill your club in your back. Okay, so you take relief. I must be totally clear of that cart path. But if I put my ball so I'm totally clear of the cart path, looks like I've got a tree in my way. So I'm just going to move the ball so it's not on the cart path and my feet will be on the cart path. I can't do that. It's against the rules. If I take relief, I must take full relief. So if I do a u substitution, I must do a full substitution. I cannot leave behind x's there. So I have to go and find the differential right here and solve for du and substitute it back in. Now, had that been an x squared, I would be in trouble. I couldn't do this. Just like not everything can be factored. Not everything can be integrated. They're going to set them up so they can be done. If they can't be done, it will be a definite integral, and it will be on the calculator part of the exam. Well, I'm going to replace 2x dx with du. So, because I'm going to do a substitution, I must substitute everything. So all these letters match, and there's du. Oh, I know how to do that one. I made it a simpler problem. Let's say it's a derivative of u cubed. U to the 4th over 4 plus c. But you know, I've started with x's, I better end with x's. So what was you? Sorry, I don't have much room. No, what was you? X squared minus 4 to the fourth over 4 plus c. I know. It is if you see it. If I, what if I don't have the 2x there? What's the derivative of this x squared minus 4 to the fourth? Well, you put the 4's, they cancel. And then you have x squared minus 4 to the third times what? Times the derivative of the inside function, which is 2x. If I don't have the 2x there, I'm going to have to cube it. I don't have a choice. That's the hard part, is how to decide the u. Let's look at the one we just did before where we squared it out. If you want to let u equal y squared plus 4y, and you integrate this, that would be u squared dy. I got a problem there. If you want to say it's y squared plus 4y to the third over 3 plus c, the 3's will cancel when you differentiate it, but what else do you have to do? Chain rule times the derivative of the inside. I need a 2y plus 4. I don't have a 2y plus 4. Can't do it that way. So you have to square it. So if it's to the 8th power, the only way I can do it is to expand it to the 8th power, which I don't want to do. I'll use a CAS calculator then. Right, only constants. No, you have to see a function and its derivative. So here's my function, x squared minus 4, and there's its derivative. So if I take this as my function, is this the derivative of my function? Yeah. If that isn't, I have problems. Because this is the chain rule. We haven't done anything with the chain rule. So I can always do u substitutions. They may not always work. Now I want to pick the function, and then I should see it's a multiple maybe of its derivative, but it's derivative. So x squared minus 3x plus 2. Okay, Grace, what's this going to be for du? Now, can I just go right to du, or do I have to do du dx? Okay, du dx, what's the derivative of this? 2x minus 3. Solving for du, I'll multiply by dx. And it's not right without the dx. Sorry about that. And if you don't put it in, I'm not saying I'm going to mark it wrong, but you're going to get it wrong because you're not going to keep track of everything. To take relief, you must take full relief. So it's the integral. Okay, this is u, right? U squared. And we said this was equal to this, obviously, which equals that. Well, I can do that. That's easy. What's that going to be? U to the what? Third over 3 plus c. But don't forget to go back to the x's. Well, we got 2 more here that are a little trickier. What was u? Well, it's the first time you've seen it. 2x minus 3 to the third over 3 plus c. How do I know that was not right? That's not u. What was u? I would go back up. Oh, x squared. How do I know I did it right? X squared minus 3x plus 2 cubed over 3 plus c. Take the derivative. And if you end up with x's here and x's there, you'd have to use the quotient rule to take the derivative. You know you did it wrong. Okay, ready to try another one?
Yeah.
Let's try number 3. And I'll write it so we can see it, because it is hard to see. It works. Okay. Looking for a function. Nope, it's times. There's really 2 choices for you. 5x squared plus 1, or what's under the radical? Actually, it's 3. Okay. You can have the square root. But if I let you equal the square root of this thing, that's going to be pretty complicated. And I don't have anything that complicated. So that's probably not a good choice. And it's trial and error sometimes. Hopefully you see it the first time. What do you want u to be? I'm looking for a function, and I see its derivative there. A derivative of 5x squared is 5x. I don't see 5x. I see 5x cubed. Well, if I let u be that, then its derivative is 10x. I don't see a 10x. So how about if we try this with you? 5x cubed plus 3x plus 2. Okay, so what's du dx? You're going to say this doesn't work either, but let's write it out and see what happens. X squared plus 10, 15. Okay, 15x squared plus 3. So du, now we have to keep track of everything. Does anybody see a relationship here? If I'm off by an x, that's a problem. But if I'm off by a number, it's not a big deal. I multiply a multiple of 3. Had this been a 2, I'd be in trouble. But it's not. So there are only so many you can do. Then you say you can't do it, but it's not going to happen. Okay, so factor out what here? A 3. So I'm left with 5x squared plus 1 dx. Now we're going to go back up here and look at this and see what we got. I have this. That's u, right? So this is going to be u. What about this? I only want 5x squared plus 1 dx. I don't want 3 of them. So what could we do? Divide by 3. Think of this as an equation because it is. Divide both sides by 3. And so now let's go ahead and substitute. So it's the integral. Now this dx with the 5x squared is du over 3. Can I go ahead and pull it 1/3 out? Are you okay with that or not? Sure. Okay, 1/3. That's the du. I usually put my differentials at the end. Standard operating procedure here. Okay, and this is the square root of u. How am I going to integrate the square root of a function? Stephen, how am I going to do that? That's u to the what? 1/2. Power. There you go. Can we do this one? Sure. What's the antiderivative of 1/2? U to the 1/2, sorry. Add up, add 1. 3. What's 1 plus a half? 3 halves. Put your phone away, Jack. Times, Jack. What? I know. Not times 3 halves, it's divided by 3 halves. So that's times 2/3. Because it's u to the n plus 1 divided by n plus 1. So dividing by 3 halves is the same as multiplying by its reciprocal. So that's 2/9, because you have to be able to do that on the multiple choice part of the test. Okay, what was u? 5x cubed, I'm going to squish it, I think, plus 3x plus 2. Okay, I didn't quite make it. Girls. They are. Okay, tell me how we're going to do this one. How about I put it on a new page? Integral of... No. I just write big. There are 2 ways to do this. And then we'll get back to this one. Okay, Zach, you guys have it? What are you going to integrate? What are you going to use for u substitution? It doesn't matter. There's 2 ways to do it. You can do just u equals 3x plus 1. what happens here? Then I still get the integral of the cosine of u times the sine of u. Oops. And du is equal to 3 dx. So that would be 1/3 du. I don't have this on my list of integrals, do I? I don't know what cosine u times sine u is. Mm-mm. Well, if I know a trig identity, I could do it. So that is a good effort, but it's not going to work. So what else would you like to try for you? That's what you do. You just try it. What would you like u to be? The cosine? Okay. Cosine of 3x plus 1. Then I'm going to get, now can we go ahead and find du this way? Du is the derivative of the cosine, which is what? Negative sine of 3x plus 1. This is okay. Times the derivative of the inside function. 3, and then dx. Remember I said we had to use differentials sometime. We were not going to go away. That is the weird pen, the calligraphy pen. Okay. This would require me to have a trig identity. I can do it. I don't want to do it though. Okay. Let's do new colors, the green. So, no, let's try it. It's the integral of the cosine. You said that was u. And this is du, except it has a what in front? Negative. Oh, it has a negative. What else? Whoops. So the sine of 3x plus 1 dx equals negative 1/3 du. Can we do that one? Yeah, we can do that one. Can't we do that one? Samuel, can we do that one? Forget the 1/3 because that's not important. It's u what? U to the first. Go up 1. Squared over what? 2 plus c. I don't know what it is, but let's go back and look. You chose it. Cosine. Flip point 1 plus c. How do you know it's right? Take. Did I forget the square? You're right. So do you want me to put the 2 here or on the outside? It's this. You can't put it around it without those extra brackets, or you can write it this way. Yes, as long as you understand that's what it is. Sure. Yeah. Because when I did the differential du, I had, unfortunately, a negative sign and a 3. I didn't want that. Well, you were going to get a 3 anyway. So the way to get rid of that is to divide by negative 3. Now it's a good match. Some people solve for dx and substitute it in and let everything cancel out. Works too. Noah. Okay, guys, I can't hear Noah. What? Dividing by the negative 3. You must keep track of everything. It's the same idea. To take relief, you must take full relief. You've got to take care of everything. Okay. Let's try that one. Now, we have 2 more examples to do. We'll leave the ones with limits of integration for tomorrow. So, you should be able to see this one, but I'll rewrite it. How should I rewrite that square root? This is in your packet now. Right here. Page 2. Jack says, why don't you write it to the 1/2 because now it looks like the power rule, which is right. Some little piece of artwork. Okay. What do you want u to be? I'm looking for the function and its derivative is just 2x cubed? You can. Okay. That will look different than my other class, but you'll get the same answer. So what's du? 6x squared dx. Now we're going to substitute everything. Okay, I want an x squared dx, not 6 of them. So what are we going to do? Divide by 6. Some of you will automatically say, oh yeah, I know what to do with that. That's fine. So that's 1/6 du, and then I'm left with 5 plus u to the what power? No, 1/2. This works. I would have let you be 5 plus 2x, but they both work, so I don't care. Remember, we took care of the x squared dx. That's equal to 1/6 of du. So this is 1/6 of du. It's all bookkeeping. It works just fine. No? If u is equal to 5 plus 2x cubed, then what's du? That's 0. Still works. I just replaced it. I substituted. I solved for, you could just solve for dx here. Dx is equal to du over 6x squared, and you could go ahead and put that right in there for dx. X squares will cancel. It's the same thing. I just see it more easily that way for me, but it doesn't matter. Now, we have to finish this, you guys. So this is 1/6. 5 plus u to the what? Okay. 5 plus u to the what power now? Go up 1. Andrew, what do you know what it's going to be? It's 3/2 times. I could do divided by 3/2. That's too much work. We're integrating. We're going up. Add 1. We're going the other way. Times 2/3 plus c. Can you do 1/6 times 2/3? It's 2/18, which is what? Well, I do too, but it's 1/9. So it's 1/9, 5 plus u to the 3/2 plus c, but I forgot what u was. We didn't use this u, did we? It works, but we didn't use it. 2x cubed. They both work. If you don't believe me, try it the other way. Because when you integrate x to the n, it's x to the n plus 1 divided by n plus 1. So I'm dividing by 3/2, but that's the same as multiplying by 2/3. Okay, one more. This is a tricky one. See if you guys can see it. I think it's tricky. Now, the homework problems, the only way you're going to get good at this is through the homework. You need practice. Did you see the cheerleader that did the flip and she had the basketball in her feet? She flipped it up over and made the basket. She's done it twice now, but wow, that was the last game of the season.
Of the kids that take gallons of milk and go to the supermarket and pretend to slip and they throw the milk on it like explodes.
No, that's got nothing to do with this.
I think so. But it was a cool video.
But you know what? She practiced. I could practice. Yeah, I could practice forever and never be able to do that. So does anybody see this one? It's kind of a trick to see it. Look back at your antiderivatives that you can do. Guys, you haven't even looked at it. Declan, look at it. That's hard. Declan, how are we going to do that one? It's not a inverse sign or anything. Doesn't even look like that. There's no square root. What's another way to say cosine squared? 1 over cosine squared. No, an inverse trig function is not a reciprocal. It's an angle. 1 over cosine of x is what? It's an identity. Yeah, you got it there.
We can. That's right.
So what is this? I didn't hear you. You're so quiet over there. I know. Okay. Now, some of you can do this without thinking, and some of you have to do a U substitution. So what would you like U to be? I know what the integral of secant squared is. What's the integral of secant squared of x? Look on your sheets. Tangent. Okay, what don't I want? I don't want the 2x. So u is equal to 2x. You say, well, I don't see its derivative, but it's a constant. So no big deal. Constants are no big deal. Variables are. So du is equal to 2 dx. So what's going to go out in front here? Is it 2 or 1/2? It's 1/2. Because if you solve for dx here, you divide by 2. Good questions. Because if you don't see it, you're not going to see it when you get home. Secant squared of u. Dx is replaced by du. Girls, you're so loud. Du. What's the antiderivative of secant squared? Tangent of u. One last thing, we got to put in what u is. U is 2x, right?
Yep.
And take the derivative. It's the chain rule. You're reversing the chain rule. It's a trick. It's a way to make this an easier problem. Oh, that one I'm going to have to think about.
Oh man, we are restricted.
How about this? I know secant of x, tangent of x. Does that help? Oh, I know what it is.
Secant squared x is the derivative of tangent.
So guess what? If this is my u, then that's my du. But here's the deal. 0 and pi over 3, are those u values or x values? Those are x. So tomorrow, because I think you've had enough for today, we will say, what are we going to do when we have limits of integration on there? There is nothing on the homework assignment that has numbers in it yet. Not till tomorrow, so we'll do it tomorrow. Guys, it's not time to go.